Right now, as you sit here watching this, something invisible is shaping the Milky Way. It cannot be seen, touched, or photographed directly. Yet its gravity is quietly controlling the motion of stars, galaxies, and perhaps even our cosmic future. This is dark matter, the hidden force that may be holding our galaxy together. They didn't expect it. That's the part history tends to forget. When the first detailed measurements of galaxies came in, quiet data, plotted with care, something was off. Not loud, not obvious, but off. Astronomers watching stars on the outskirts of spiral galaxies noticed something disturbing. They were moving too fast, stars on the edge of a galaxy, like leaves at the end of a branch, should drift slowly, pulled just enough by the mass at the center to stay in place. That's what Newton's laws told them. The farther a star is from the core, the less gravitational grip. That's how our own solar system works. Mercury whips around the sun, but Pluto drifts, leisurely and distant. But when they looked at Andromeda, at NGC 3198, and eventually at our own Milky Way, the stars weren't slowing down. They were flying through space at speeds that shouldn't be possible. If they were relying only on the visible mass, the stars, the dust, the gas, they should have been flung into the void, unanchored. But they weren't. They stayed, orbiting, steady, as if held in place by something unseen, something vast, something silent. It was as though a hand we couldn't see was gripping every galaxy by its outer rim and refusing to let go. At first, the reaction was confusion, then suspicion. Maybe the instruments were off, maybe the measurements were flawed. But as more observations came in, from radio telescopes, from infrared surveys, from observatories high in the mountains and low in Earth's orbit, the pattern refused to disappear. It became a contradiction, and contradictions in science are never small, because the laws of gravity had always worked. In our solar system, in simulations, in predictions, but now, in the open sky, galaxies were defying them. Something was wrong, not just with the galaxies, but with the framework we used to understand the universe. And so, reluctantly, a term was born, not out of discovery, but out of absence. Dark matter, not because it's black, not because it hides in shadow, but because it does not emit or reflect light. It cannot be seen. It cannot be touched. It doesn't collide. It doesn't glow. And it doesn't burn. But it does something else. It pulls. It exerts gravity, not as a trace, but as a force more dominant than the matter we can see. In fact, when astronomers ran the numbers, they realized something staggering. Everything we know, stars, planets, galaxies, nebula, all the shining matter in the cosmos accounts for only about 15% of the gravitational mass. The rest is invisible. That means most of the universe is made of something we didn't even know existed until our own tools betrayed us. And so it began, this slow, spiraling realization that we are moving through a cosmos shaped by an invisible architect, one that does not speak, does not shimmer, but is everywhere. Dark matter is not like the blackness between stars. That emptiness still holds photons, still contains gas. This is darker than dark, not just invisible, but indifferent. We can't shine light on it. We can't scoop it up, but we can feel its hand, always, holding galaxies together like thread in a spinning wheel. And our own galaxy, the Milky Way, is no exception. Even now, our solar system orbits the galactic center at 828,000 kilometers per hour. At that speed, we complete one revolution every 230 million years. And yet, we are not flung outward. Why? Because the stars alone aren't holding us in place. They don't have enough mass. Something else is anchoring the spiral. Something we didn't ask for. Something that has been here from the beginning. And here is where the contradiction deepens, because we have no idea what it is. Every attempt to detect dark matter directly has failed. We've built chambers deep underground, thick with lead, shielded from radiation, hoping to catch a whisper of its passage. We've fired particles in accelerators, watched for subtle recoils, listened for decay. Nothing. The most dominant matter in the universe remains the most elusive. It's like chasing a ghost whose only evidence is footprints in stone. And yet, the footprints are everywhere, in every rotation curve, in every spiral arm that doesn't drift away, in every galaxy that holds its shape across billions of years. And so we're left with a presence that refuses identity. We know it exists, not because we see it, but because nothing else makes sense without it. It shapes our models, it defines our maps, and still, it remains unknown. Some scientists believe dark matter might be a kind of particle, massive, slow, cold. Others think it could be a field, a memory, or a flaw in gravity itself. But all they agree on is this: without it, the universe would fall apart. And this is where the mood shifts, from curiosity to something else. Because what does it mean to live in a world where the most important force, by mass, by reach, by scale, is one we cannot know? What kind of story is this, where the main character never shows their face? There's something deeply unsettling in that. Not terrifying, not chaotic, just alien. And yet strangely, comforting. Because dark matter doesn't act like a monster. It doesn't lash out. It doesn't disrupt. It holds, quietly, constantly, as if its only purpose is to keep the spiral from falling apart. Maybe that's what presence really means. Not what we see, but what we cannot escape. The mass that shouldn't be there is, not because it was added, but because it was always there, waiting for us to realize we'd missed something fundamental. And perhaps that's the greater mystery. Not that dark matter is hidden, but that we built an entire model of the universe without ever knowing it was there. So what else have we missed? Because if the edges of galaxies are bound by something invisible, then perhaps the entire structure, everything from center to arm to halo, depend on a skeleton we've never seen. And that brings us closer. inward, toward the Milky Way itself, toward a spiral not just suspended in space, but structured by shadow. If dark matter isn't just a ghost on the edge, but the foundation, then the galaxy we call home may be built on something far stranger than we imagined. We picture the Milky Way as a spinning wheel of stars, bright, majestic, sweeping across the dark, a glowing disk of suns and dust edged with spiraling arms. But this image, while beautiful, is a lie of omission. It shows us only the part that shines. The real Milky Way, the full structure, is far larger, far stranger, and most of it is made of things we can't see. The stars, the planets, the glowing gas clouds. They're just the surface, a kind of luminous skin. Beneath that, around it, through it, lies something else, something without light, without form, without collision. And without it, the spiral would collapse. When astronomers try to simulate the galaxy using only what we can observe, using every atom of every known star, nebula, and solar system, it falls apart. The spiral arms twist and disband. The core bulges too fast. The outer regions drift into space. But when they add something invisible, an unseen mass surrounding the disk in a vast halo, the simulation begins to work. Stars stay bound. The spiral holds its shape. The galaxy becomes stable. Dark matter doesn't simply fill in the gaps. It defines the structure. It's like discovering that the architecture of your home doesn't rest on stone or wood, but on scaffolding you never noticed. A frame that was always there, silent and essential. And this halo, it isn't small. It extends far beyond what we think of as the galaxy. Our luminous Milky Way stretches maybe 100,000 light-years across. But the dark matter halo that holds it, it spans more than 1 million, 10 times wider, perhaps more. A ghost structure so vast it dwarfs the stars, a presence without surface, shaping everything. And it's not a shell, not a wall, it's a sphere. A loose, fuzzy sphere of mass that surrounds the galaxy like an invisible globe, thickest at the center, fading toward the edge, but always there. It doesn't glow. It doesn't clump. It doesn't interact with electromagnetic forces the way normal matter does. But it shapes gravity, which means it shapes motion, which means it shapes everything. Galaxies aren't born from stars clustering together. Not really. They're born from halos, huge wells of dark matter pulling gas into dense regions where stars can ignite. In this view, dark matter doesn't just support the galaxy. It precedes it. It's the mold into which light is poured. A template for structure long before anything visible arrives. And once you see that, the metaphor changes. The galaxy isn't a disk floating in space. It's a system suspended inside a field. And fields don't forget. Some of the stars in our galaxy don't behave like locals. They travel at odd angles. They form streams. They behave as if they once belonged somewhere else. That's because they did. The Milky Way has swallowed other galaxies, consumed them over time. When this happens, Their stars are absorbed, but their dark matter halos don't vanish. They blend. They expand the reach of the original. The current halo of the Milky Way is a composite, the memory of a dozen smaller galaxies folded into a single shape. It's a layered field, a record, and this record doesn't fade because dark matter doesn't decay like stars. It doesn't collapse into white dwarfs. It doesn't explode in bursts. It persists, which means the galaxy we live in isn't just vast. It's ancient in a way we're only beginning to understand. The halo isn't just mass, it's memory, and we are floating in it. Right now, as you listen, Earth is moving through that invisible field, suspended in a web we can't detect directly, shaped by forces we only know by their pull. We orbit the center of the galaxy not just because of the stars and gas at its heart, but because we are embedded in a gravitational envelope so huge it defies mapping. And this halo, it doesn't stop at the edge of the disk. It doesn't wait for permission to exist. It encompasses. The stars are caught inside it like dust in a snow globe. It raises a quiet, uncomfortable question. What is the real shape of the Milky Way? Not the glowing spiral we paint on posters, but the structure that actually holds us. A fuzzy sphere of gravity and silence, with a disk of stars shining quietly inside. The light is the illusion, the dark is the form, and once you accept that, everything changes. We stop thinking of dark matter as decoration or leftover scaffolding. We begin to ask, what is this halo doing? Is it static, dynamic? Does it shift as the galaxy ages? Could it be evolving? Some models suggest it might respond to motion within, that the distribution of dark matter may be altered by major events, galactic collisions, core explosions, supernovae cascades. If true, this means the halo isn't just a support beam. It's part of a feedback loop. The stars are not separate from the dark. They are expressions of its contours. And then quietly, another idea arises. If galaxies require dark matter halos to form, if stars emerge inside these invisible envelopes, then perhaps everything we know as visible is a secondary layer. The light comes after. The visible follows the invisible. This reverses the normal way of thinking. We imagine dark matter as an addition to explain a mystery. But what if it's the starting point? The thing that defines what a galaxy can become? That's when the stars become skin, traces of a deeper, older structure. A surface stretched over a hidden anatomy. And perhaps this anatomy isn't unique, because every large galaxy we've measured has its own dark matter halo. Not one exception. Even elliptical galaxies, irregular ones, the distorted shapes of early cosmic time. They all appear to sit inside these massive, invisible spheres. It's as if the universe is built on dark scaffolds, as if every island of light we can see was grown inside a mold we can't. And here we find a new way to see the cosmos, not as scattered dots in a void, but as nodes suspended in an unseen web. Each galaxy, a lantern inside a field. Each star, a flicker on the surface. Each orbit, a whisper of the structure beneath. And dark matter, The quiet architect, present from the beginning, persisting through every collision, framing every spiral, holding us not with force, but with shape, a shape we only discovered because the galaxy refused to fall apart. And so we follow this scaffolding now, from the halo back toward the core, inward, into the spine of the Milky Way, into the place where its mass is densest, where gravity folds into complexity. If the stars are just the skin, then what lies beneath the heart? Sometimes science advances not through discovery, but through contradiction. In the 1930s, Swiss astrophysicist Fritz Zwicky was studying a galaxy cluster called Coma, a group of more than 1,000 galaxies bound loosely together, floating in deep space. He wanted to calculate the total mass of the cluster by adding up all the light-emitting matter, stars, dust, gas, and then, using the galaxy's velocities, he would check whether the cluster was gravitationally stable. But something didn't add up. The galaxies were moving too fast, much too fast. According to his calculations, the visible matter wasn't nearly enough to hold the cluster together. It should have been flying apart, but it wasn't. It was as if something unseen, something massive, was anchoring the entire system in place. Zwicky didn't have a name for it. He called it Dunkel Materia, dark matter. Not because it was mysterious, but because it didn't shine. At the time, no one listened. His peers dismissed it. The data seemed shaky. The theory felt awkward. And besides, why add something you can't see just to make the math work? But decades later, the same problem reappeared. Not in clusters this time, but in galaxies themselves. In the 1970s, Vera Rubin and Kent Ford began studying the motion of stars within spiral galaxies. They expected the velocity of stars to decrease with distance from the galactic center, just like planets in a solar system. That's how gravity behaves. The farther out you go, the weaker the pull. But that didn't happen. The stars on the edges were moving just as fast as the ones near the middle. They weren't slowing down. They were maintaining speed in defiance of Newton and Einstein alike. The only explanation? There was more mass than they could account for. Much more. Something invisible was influencing the stars. Again, the data whispered the same thing Zwicky had once shouted. There was more in the universe than meets the eye. But still, no direct proof, no detection, no light, only the math. Dark matter hadn't been seen. It had been inferred. It appeared in the equations not as a discovery, but as a patch, a necessary correction to prevent the entire model of the universe from unraveling. And this is where the story begins to twist, because science doesn't like holes in its models. And yet, rather than abandon the laws of gravity, physicists inserted a new entity into the equation, one that could explain the mass, the speed, the structure. Dark matter became a placeholder, a mystery given just enough name to hold space. It was no longer about what it was, only what it did. It pulled, it stabilized. It made the rotation curves work, and in time, this placeholder began to take on more weight. It crept into simulations. It explained not just galaxy motion, but cosmic structure. It accounted for galaxy formation, cluster stability, even the growth of the universe itself. Dark matter was never directly observed. It was simply the only idea that kept the math alive. And so, like scaffolding added after a building had already begun to fall, it became part of the architecture. But there's something haunting in that. Because once you invent a force to fix your framework, you're no longer discovering, you're constructing. Dark matter wasn't discovered. It was invented to keep reality from collapsing. That's not to say it isn't real, only that it was born from necessity, not evidence. And necessity is a strange midwife. The more simulations relied on dark matter, the more central it became. The more telescopes failed to detect it, the more elusive it felt. It became the silent majority of the universe. A shadow force we built the modern cosmos around, but couldn't explain. It started to feel assumed, like gravity, like time, always there, but never touched. And that's the paradox. Science needs evidence, but the deeper you go into cosmology, the more it builds around things we can't measure. What does that say about the universe? What does that say about us? We prefer light. We prefer proof. But the cosmos offers silence. And we've built a model of everything: galaxies, clusters, motion, expansion. On top of that silence, a silence we filled with a name: dark matter. It is both elegant and unsettling, because if dark matter wasn't demanded by the data, would we believe in it at all? Or have we gotten so used to the idea that we've stopped questioning where it came from? We know how it behaves, we know what it should do, but we don't know what it is. That difference matters, and that's where this mystery sharpens. Because to truly understand dark matter, we must look past its behavior and into the theories that try to define it. But what we find there is not a single answer, only chaos and imagination and possibility. The name dark matter suggests something singular, a substance, a hidden element waiting to be found. But when you open the box, when you look closely at what scientists think dark matter might be, you don't find one idea. You find a storm of particles, possibilities, exotic theories, and contradictions. One of the earliest candidates was the WIMP, the weakly interacting massive particle. It fit the bill perfectly. It had mass. It didn't interact with light, and it behaved just enough like matter to be modeled. But decades passed. Experiments were built, detectors buried deep underground, hoping to catch a WIMP in flight. None were found. Then came the axion, a hypothetical particle so light it could pass through entire planets without a trace. It might make up cold, dark matter, or it might not exist at all. Its name, playful, came from a brand of detergent, as if it might help clean up cosmic equations. Sterile neutrinos offered another route. Neutrinos that didn't interact with the weak nuclear force. Ghosts even among ghosts, elegant on paper, invisible in practice. Then there were the machos, massive compact halo objects, brown dwarfs, primordial black holes, strange heavy things that emit no light but exert gravity. For a time, they were serious contenders, but like all the others, they began to fall. Too rare, too heavy, too uncooperative. Each failure didn't close the door, it opened more. With every dead end, theorists proposed new particles, dark photons, fuzzy dark matter, supersymmetric partners. Some of them stretched the fabric of known physics, others rewrote it entirely. And still, no detection, no signal, no particle we could pin to the board. It was as if nature was playing a game with us, giving us the clues, giving us the symptoms, but hiding the source. And so the field began to split. Some researchers clung to the particles, believing the answer lay just beyond current technology. That with better detectors, colder chambers, more sensitive tools, we would catch the thing we invented. Others turned philosophical. They began to ask whether dark matter was even real in the way we assumed. What if gravity is wrong at large scales? What if we're misreading the universe entirely? Modified Newtonian dynamics, M1D, emerged as an alternative. It adjusted the laws of gravity rather than invent new matter. But M1D didn't explain clusters. It didn't scale well. It felt like a local fix for a global problem. So the theories grew wilder. Dark matter as a field rather than a particle. A ripple in space-time. A byproduct of extra dimensions. A shadow of a parallel universe bleeding into ours. Or perhaps dark matter is not out there at all. Maybe it's a mathematical artifact. A mistake in how we interpret the shape of space. In one theory, the missing mass is an illusion, caused by the curvature of the universe at scales we can't observe. In another, it's information, an unseen code baked into the structure of reality. And here, the line between science and metaphysics begins to blur. We're no longer asking, what is dark matter made of? But what kind of reality would require something like dark matter to exist? It's unsettling, not because there's no answer, but because there are too many. The models work, the equations fit, but every explanation demands we rewrite something else. And so we're left with a paradox. To understand the visible, we filled the universe with things we've never seen. It's like painting a portrait using invisible ink, tracing shapes we can't see to describe a face we can't touch. Dark matter sits at the edge of what science allows. It is defined only by its consequences. It pulls, but doesn't glow. It shapes, but doesn't speak. It might be particles, or fields, or math, or memory. We don't know. And that is its power, because in the space of not knowing, we imagine. We build castles from equations. We create frameworks that hover in air. It's tempting to see this as failure, but maybe it's something else. Maybe dark matter is not a problem to be solved, but a mirror, reflecting how much we don't understand, how much room there still is to wonder. And so we wonder, and we search, not for what dark matter is, but for how it acts. Because if we can't see it, maybe we can still feel it. Light, we're told, travels in straight lines. It moves from source to eye in a clean, perfect path, unless something interrupts it, unless space itself bends. And space does bend, not metaphorically, not visually, but physically, folded and curved by the mass it contains. The greater the mass, the more dramatic the curve. This is not a theory anymore. It's a fact. Einstein predicted it. Gravity, he said, is not a force pulling objects across a flat void. It's the shape of space itself, warped by matter. And when space curves, light follows. The universe bends light, and in that bending, we can see what isn't there. Imagine a distant galaxy, billions of light years away. Now place a massive object between it and us, another galaxy, or a cluster of them. The light from that distant source will travel around the obstacle, distorted by the gravity in its path. It arrives not as a point, but as a smear, a curve, sometimes a ring. We call it gravitational lensing, and it's one of the most elegant tools ever discovered for seeing the invisible. Because when astronomers began to examine these distortions carefully, measuring how light bent, where it stretched, they found something strange. The light wasn't bending around visible matter alone. It was bending around mass that couldn't be seen. In every direction they looked, galaxies and clusters were acting like lenses too heavy for their visible contents. Their light warping power was out of proportion, too strong, too smooth. And so, by tracing how background light was distorted, by mapping the shape of the lens, we began to draw outlines of what couldn't be seen. We began to map dark matter. It wasn't a photograph. It wasn't direct detection, but it was clear. There was mass where no mass should be. This is where dark matter stopped being an abstraction and became a structure. Something with shape, presence, texture. Not a theory anymore, but a field. Entire clusters, like the bullet cluster, showed the effect most vividly. In one of the clearest examples to date, astronomers observed two galaxy clusters in the process of colliding. The visible matter, mostly hot gas, slowed down and piled up, as expected. But the gravitational lensing didn't follow the gas. It followed the galaxies. It split from the light. It pointed to mass that had passed through unaffected. The conclusion? Most of the mass was dark, and it didn't collide. It didn't heat. It kept moving, like a ghost through smoke. And there it was, written in warped light, the signature of something that doesn't want to be seen. We can't see the ghost, but we can watch it move the furniture. This changed everything, because it meant we could study dark matter without touching it, without catching it. By simply measuring how it deforms light, we could weigh the universe. Weak gravitational lensing, subtle distortions barely perceptible, became a way to measure the large-scale structure of the cosmos. Satellite missions like Planck and Euclid use it to map the invisible skeleton of space. And what those maps show is chilling. A web, a lattice of dark matter stretching across the universe. Clumps and strands, dense knots where galaxies form. Vast, cold voids where light barely dares to pass. This is the true architecture of the cosmos. The stars are ornaments, the galaxies, passengers. The structure belongs to something else, and still it remains quiet. Gravitational lensing gives us a way to see dark matter's influence, but it offers no answer to what dark matter is. Only what it does. It pulls, it bends, it sculpts the sky. It reveals itself only by how it shapes others. And here, another unsettling thought appears. Maybe dark matter isn't the exception. Maybe it's the baseline. What if we've been looking at the universe inside out, treating visible matter as the standard, when in fact, it's the anomaly? Dark matter is everywhere. Light is rare. Perhaps light is the flare, the signal, and the darkness is the field it signals from. The more we map the distortions of background galaxies, the more consistent dark matter becomes. It forms halos around galaxies, bridges between them, tethers in clusters. We can't detect a single particle, but we can measure the mountain it casts. And what's more, these gravitational maps don't just show presence, they show structure, order, as if dark matter isn't random, but arranged, organized by laws we've only begun to guess. And if that's true, then something vast and unlit is shaping space not by accident, but by design. We've learned to see this field indirectly, to weigh the unseen, to trace shadows by their bend in the mirror of light. But now the question tightens. If gravitational lensing shows us how dark matter behaves across the cosmos, what does it do here, in our own galactic backyard? What does the invisible field look like from inside the halo? The answer may be even stranger than we think. We tend to think of dark matter as distant, a force that operates on cosmic scales, beyond reach, something that shapes galaxies but stays politely outside our walls. But that's not true. Dark matter is here, around us, inside us, flowing through our galaxy, not as a boundary, but as a presence. The Milky Way, like all large galaxies, is embedded in a dark matter halo. We are not on the outside of it, observing from a safe distance. We're within it. That means every motion, our orbit, our solar drift, the path of our sun and its planets, is being shaped by a gravitational field we can't see. It's not just something holding the galaxy together. It's something shaping our everyday movement through space. And that leads to a strange realization. Dark matter isn't out there. It's here. Right now, as you sit, trillions of dark matter particles may be passing through your body. They don't collide. They don't spark. They don't even slow down. They move through the earth like wind, through netting, unstoppable, untouchable, but present. Some estimates suggest that a single dark matter particle passes through every square centimeter of Earth every second. More through your body than photons from a light bulb, yet no sensation, no trace. And still, They shape everything. The rotation of our galaxy, the orbit of the sun, the long, slow bobbing of our solar system through the galactic plane. All of it under the hand of something invisible. So scientists asked, can we catch it? The effort began quietly. A room deep underground, then another. Then entire networks of detectors buried beneath mountains, shielded from cosmic rays, wrapped in lead and silence. Experiments like Xenon 1T, Lux Zeppelin, and Dharma Libra were built to detect the faintest sign of interaction. A single particle hitting a xenon atom. A tiny flash, a shiver of motion in the dark. But years passed, and nothing definitive came. Some experiments reported seasonal signals, tiny annual changes that matched our planet's movement through the halo. For a moment, hope sparked, but follow-ups were inconclusive. The signals danced just out of reach. It's like trying to catch a wind that doesn't push. Still, the detectors wait, perfectly still, hoping for a whisper. Because if dark matter can pass through us, maybe it can also speak. Not in words, not in energy, but in influence. Some theorists suggest that dark matter may interact through a force we haven't discovered yet. A dark electromagnetic field or a shadow photon. Something subtle, something real. Others propose that dark matter is part of a larger symmetry, one that includes our matter, but also balances it. As if for every particle in us, there is a dark counterpart moving alongside, unseen. And some ideas go further. They ask whether dark matter may not be completely indifferent. What if it interacts weakly, but intentionally? Not like a person, not like a will, but like a system, structured, patterned, responsive. The idea seems strange, but consider this. We only think it's unresponsive because our tools expect a collision. But what if dark matter works differently? What if it whispers instead of knocks? Our galaxy rotates as if wrapped in invisible thread. That thread moves with us. It surrounds us. It enters us. And yet, we treat it as background noise. Maybe it isn't. Maybe it's the field we were born inside. A condition of motion so fundamental we no longer question it. And if we could understand its rhythm, we might understand our own. Because the Milky Way is not just a place, it's a system. And systems have structure, feedback, response. So we ask again, is dark matter interacting? Is it part of a loop that includes us? Or is it still a ghost, wandering past, affecting us only with the weight of its silence? If we are within the halo, then we are part of its story. And that means the next question is not about movement, but about influence. If dark matter flows through everything, galaxies, planets, bodies, could it also shape life? That's where we go next. We tend to place biology in a separate box. Life, we believe, is Earth's domain. A chemistry of cells and carbon, water and sunlight. It is shaped by climate, mutation, catastrophe, and time. But what if we're missing something? What if life itself, its timing, its fate, has been influenced by forces we cannot see? Not by gods, not by chance, but by dark matter. That invisible presence we've followed across galaxies, mapped in halos, chased in underground labs. What if it's been here all along, not just sculpting the cosmos, but shaping the rhythm of life? It sounds wild, and yet, some scientists are starting to ask the same question. Because when we look at the history of life on Earth, a pattern begins to emerge. Not a perfect one, but persistent enough to haunt. Roughly every 26 to 30 million years, Earth seems to experience a mass extinction event. A sudden die-off, a great forgetting. The dinosaurs were not the first, nor the last. Species vanish, ecosystems collapse, and then, slowly, life returns. What causes these cycles? Some blame comets, others point to volcanic activity, shifting plates, climate instability. But a few researchers have looked higher. They noticed that the Sun, and by extension, our entire solar system, doesn't simply orbit the galaxy in a flat path. It moves in a gentle wave, oscillating above and below the galactic plane, like a buoy drifting in a slow, unseen current. Roughly every 30 million years, we cross the densest region of the Milky Way's dark matter halo. A coincidence? Or something more? If dark matter is dense enough in those mid-plane regions, then our passage through them might trigger gravitational or energetic events, perhaps nudging comet clouds, disrupting planetary balance, even altering biological systems on Earth through forces we don't yet understand. It's speculative, but grounded in data. The timing lines up. The oscillation matches, and suddenly, life on Earth feels less like an isolated chemical accident, and more like a participant in a cosmic tide. If dark matter affects gravity, it could alter how radiation from the Sun reaches Earth. If it interacts with neutrinos or other subatomic particles, it could influence DNA. And here the boundary begins to blur, because what we call biology is not separate from physics. Life is structure, vibration, feedback, and if dark matter moves through all of it, then it may not be neutral after all. It may be involved. Some researchers go further. They ask whether certain epochs of evolutionary explosion, such as the Cambrian, when life diversified wildly, could be linked to galactic conditions, surges in dark matter density, gravitational compression, invisible events that shaped life from the outside in. Others suggest a concept even stranger: dark biology. The idea that dark matter may not just influence life, but that a form of life could exist within the dark sector itself. Not made of atoms, not bound by our chemistry, but still structured, still responsive, still capable of evolution, though on scales or by laws we can't yet conceive. In this model, life as we know it is only one expression of an underlying pattern that spans both visible and invisible matter. What would that life look like? We don't know, but perhaps it doesn't look like anything. Perhaps it moves through galaxies the way dark matter does, untouchable, persistent, surrounding everything. Not life as object, but life as field. Not consciousness in a body, but intelligence in motion. Of course, mainstream science hesitates. The data is thin. The models are speculative. But the questions remain. Why do extinction events follow cosmic rhythms? Why do some periods of life explode with innovation and others fall silent? Why do we assume the forces shaping biology are only local? Dark matter isn't local. It's everywhere, flowing through us, through planets, through cells, without detection. And yet, things respond. What if Earth is not just a rock in orbit, but a sensor moving through layers of the galaxy? What if life arises not just from chemistry, but from location? If that's true, then we are children not just of the Earth, but of the halo that holds us. We live inside the dark matter field. We evolved inside it, and that means we carry its influence, written not in myth, but in molecule, and perhaps in memory, because extinction is not the end. It's a clearing, a resetting, and after every great die-off, something new emerges, smarter, faster, more complex. What chooses the timing? What governs the leap? We don't know, but maybe it's not random. Maybe dark matter doesn't choose, but maybe it enables. Maybe it provides the pressure, the structure, the unseen hand nudging evolution forward, not directly, but by setting the stage. And suddenly, biology becomes cosmic, life becomes galactic, and death becomes a turning of the page, not a closing of the book. The thought is strange, but comforting, because it means we're not adrift. We're in orbit, not just around a star, but through a rhythm, a wave, a structure we cannot see, but may have always felt. And now, we must ask the next question. If dark matter can shape life, might it also relate to something deeper? Not just the body, but the mind, consciousness, that spark behind the eyes, the awareness that says, I am. Science has spent centuries trying to pin it down. Neurons fire, chemicals shift. But the mystery remains. How does matter become mind? We search the brain. We map activity. We watch thoughts flicker across imaging screens. But nowhere do we find the source. And so, some begin to look elsewhere. Not inside the skull, but outside the body, across galaxies, into the structure of space itself, and into the dark. Because if dark matter shapes everything, mass, structure, motion, why do we assume it has no role in awareness? We often speak of consciousness as an emergent property, something that arises from complexity. Enough connections, enough loops, and the system becomes aware. But complexity alone doesn't explain the feeling of being alive, the presence, the self. Some researchers have proposed that consciousness isn't something the brain creates, but something it receives, like a radio tuned to the right frequency. If that's true, Then where does the signal come from? One possibility. It emerges from the fabric of the cosmos itself. Cosmopsychism, the idea that the universe contains consciousness in its structure, and that individual minds are fragments of a greater whole. Not metaphorically, but literally. In this model, the field of awareness is as real as gravity, and like gravity, it requires a medium, something stable, omnipresent, undetectable, something like dark matter. We don't say dark matter is conscious, only that it may be part of the medium through which consciousness operates, like the wires behind a screen, silent, passive, but necessary. And when you realize that dark matter flows through us, through planets, brains, galaxies, then the lines begin to blur. Because what if awareness is not confined to biology? What if it's entangled with structure? What if dark matter, with its ghostly presence, its consistency, its silence, is the substrate upon which the experience of self is written? Quantum physics hints at this entanglement. Particles influence each other instantly across distance. Observation changes outcomes. Matter seems to know when it's being watched. It doesn't prove consciousness is cosmic, but it suggests that awareness and matter are not as separate as we thought. And if that's true, then dark matter, by virtue of being everywhere, might be part of the same system. Some researchers suggest that the gravitational fields generated by dark matter could shape how information is stored, not in the brain, but in the relationship between things. Consciousness as relation, not object, not confined to flesh, but woven into space. Perhaps the feeling of being alive doesn't emerge from the brain at all. Perhaps it emerges from the field the brain swims in, a field shaped by dark matter. This is speculative, unproven, but the symmetry is haunting. Everywhere consciousness exists, dark matter also flows. And if it flows through everything, untouched, unfiltered, always present, then maybe it doesn't hold awareness. Maybe it mirrors it. A dark mirror, reflecting without response, present without reply. A backdrop that echoes the self back to itself. We assume consciousness ends at the skin. But what if it begins in the stars? What if the sense of self is not isolated, but extended from neuron to planet to halo? And when we close our eyes, when we drift beyond thought, maybe we're brushing against that field, not leaving the body, but remembering the space it's floating in. This doesn't make dark matter divine, but it makes it relevant, not just as a gravitational glue, but as part of the hidden framework of awareness itself. And in this light, the galaxy changes. It becomes not just a system of stars, but a nervous system, a structure with memory, pattern, potential, and we, tiny sparks within it, may not be as isolated as we thought. We are inside the field, inside the spiral, inside the mind, or something like one, which leads to a final question. If dark matter shapes life, if it reflects consciousness, could it also be shaping the destiny of galaxies? That's where we go next. There's a quiet rule in astronomy. Galaxies need dark matter to stay whole. Without it, they spin too fast. Their stars would scatter. Their arms would unravel. The entire structure would come apart like leaves caught in a storm. Dark matter, we're told, is the invisible glue holding galaxies together. But some galaxies don't listen. They move strangely. Too fast, too slow, too smooth, too rough. They break the rules, not loudly, but consistently, raising a quiet question beneath every data set. What if the model is wrong? Take NGC 1052 DF2, a ghostly smear of stars floating in space like a ripple in fog. It's ultra-diffuse, barely visible, and yet stable. And here's the problem. It seems to have no dark matter at all. When scientists measured its motion, they expected the usual discrepancy. But the visible stars accounted for almost all the gravitational effect. There was no need to invoke dark matter. None at all. A galaxy without glue. Then came DF4. Same story, same silence. Two galaxies, similar structure, similar composition, moving as if the dark field around them simply wasn't there. At first, these were seen as outliers, flukes, statistical accidents. But more examples followed, and they weren't all missing dark matter. Some had too much. Tiny dwarf galaxies, barely more than clumps, surrounded by halos far greater than their size, seemed to warrant. Ultra-compact galaxies rotating with the energy of giants. And then there were the ultra-diffuse galaxies, UDGs. They look like ghosts, spread thin. Their stars are sparse, dim, unassuming. They barely glow, but they don't fall apart. Something holds them. Not mass, we can see, but structure. Gravitational force not matched by starlight. A presence without a face. So what's happening? Is dark matter acting differently in different places? Are we measuring wrong? Or is there something deeper at play? Something beneath the theory? Because these galaxies, too fast, too faint, too empty, don't just bend the rules. They bend the question itself. If dark matter is everywhere, why isn't it everywhere the same? We thought it was passive, uniform, a kind of background fabric. But maybe it isn't. Maybe dark matter responds to context. Maybe it clumps around some galaxies, avoids others. Maybe it flows, learns, remembers. Or perhaps the galaxies are shaped by something more complex than mass alone. Maybe they're being architected. Think of a galaxy not as a collection of stars, but as a result, the outcome of a recipe. Ingredients: hydrogen, helium, time, and something else, an unknown force, an organizing principle. A rule we haven't discovered. Maybe dark matter isn't a singular substance. Maybe it's a spectrum of effects, some gravitational, some informational. Because when we simulate galaxies, we assume uniform conditions. Same dark matter profile, same parameters. But the universe laughs at uniformity. It plays with form. And some galaxies are too well formed, symmetrical, ordered, balanced in a way that hints at design, not in the religious sense, but in the mathematical, as if structure itself is being guided. There's a theory known as emergent gravity, the idea that gravity isn't a force, but a side effect of information moving across space. In this model, galaxies form not because of invisible mass, but because of how information is distributed across space-time. It's radical. It hasn't been proven. But it fits the pattern, because the anomalies, DF2, UDGs, dark matter-rich dwarfs, aren't just exceptions. They may be data points from another system, a hidden architecture. Dark matter, in this view, becomes not just mass, but method, a set of instructions, not a thing, but a behavior, a tendency. A galaxy doesn't hold together because something glues it. It holds because the instructions for structure are embedded in the fabric of the cosmos. In that sense, galaxies that shouldn't exist aren't breaking the rules. They're showing us a deeper one. And here's the twist. What if we've been looking at the wrong layer? What if dark matter is the shadow of a deeper pattern? Galaxies as expressions, not accidents. Stars as symptoms, not causes. Structure as echo, not explosion. And what if that structure is shared across galaxies, across time, across the lattice of space? That's where we go next. Because if these hidden architects shape galaxies individually, what do they build when galaxies connect? Zoom out far enough, and the universe stops looking like stars. It begins to look like threads. Billions of galaxies, stretched across space, don't sit randomly. They cluster. They drift toward each other. They form walls, filaments, knots of matter interlinked by invisible bridges. And between them, vast cold voids, regions so empty that light barely passes through. This isn't artistic metaphor. It's the structure of reality. The universe is not smooth. It's woven. And the threads of that weave, what scientists call the cosmic web, are built not from stars, but from something deeper. They're built on dark matter. At the largest scales, dark matter doesn't just form halos around galaxies. It forms the roads between them. It shapes where galaxies go, where they form, where they cluster, where they vanish. Imagine a spider's web in the dark. You can't see the strands, but you can see the dew clinging to them. Galaxies are the dew. Dark matter is the silk. And here's where it gets strange. This web isn't static. It's evolving, changing, reacting. Simulations show that galaxies form at the nodes, where dark matter filaments cross. And those nodes grow over time, pulling in matter, shaping gravity, feeding clusters. But something else is happening too. Galaxies across billions of light years show unexpected alignments. Their spins, their motions, subtly correlated in ways that defy randomness. Why should galaxies, separated by cosmic distances, align? Is the web not just structure, but signal? Some physicists believe the cosmic web may encode information, that its shape reflects not just gravitational behavior, but a deeper set of instructions, a framework for how reality grows. In this light, Dark matter is not just scaffolding, it's syntax. And the galaxies? They are the sentences. Some researchers now explore whether the web is a memory system, a record of formation, collision, entropy, not in matter, but in shape, in tension, in curve, like a brain storing history in the way its cells connect, or like DNA, encoding function in the twist of a spiral. The structure is too elegant, too efficient. It minimizes energy. It maximizes distance. It behaves like design, not imposed, but emergent. And if it is information, then perhaps dark matter is not matter at all. Perhaps it's structure, behaving like substance. The difference matters. Because matter decays, structure persists. And here the idea returns. Maybe galaxies aren't separate. Maybe they're nodes in a larger organism, beads on an invisible string, organs in a greater body, echoes of a pattern too large to see all at once. And if that's true, then our Milky Way is not isolated. It is connected through invisible threads, through gravitational rhythms, through a system that may be older than light. And dark matter, it's the medium that binds it all. A field, a code, a silence that speaks only through form. And if this is true, then the question isn't just how galaxies form. It's why. Because structure implies purpose, and purpose implies meaning. And meaning implies something we haven't yet dared to name. But before we go there, we must pause. Because not all space is structured. Not all regions obey the web. Some places are empty, and what we find in those voids may rewrite the entire story. For something we cannot see, dark matter is oddly dependable. It holds galaxies together. It shapes their halos. It stretches across the universe in filaments, building the web that gives the cosmos its form. And yet, there are places where dark matter seems to go missing. These are the quiet contradictions, the anomalies that sit patiently in observational data, waiting for someone to stop looking for confirmation and start listening to exception. Because dark matter is supposed to be everywhere, uniform, omnipresent. That's how the models work. You don't pick and choose gravity. It picks you. But in some places, it doesn't. Take cosmic voids, vast, cold regions between the strands of the cosmic web. They aren't just empty of stars. They seem to lack mass entirely. These voids can span hundreds of millions of light years. And according to theory, even these empty regions should contain dark matter, thin, diffuse halos of invisible mass. But when astronomers map gravitational lensing through these regions, they find almost nothing. Not low density, none. It's as if dark matter skips them entirely, or avoids them, or flows around them like water circling a drain. Why would something defined by gravity resist the very shape that gravity pulls into? We don't know, and that's the beginning of a deeper mystery. Because these aren't isolated cases. Some galaxies, like DF2 and DF4, also appear to lack dark matter. Others, expected to have rich, dark halos, appear impoverished, and when galaxies pass through voids, their behavior shifts. Star formation slows, rotational curves flatten, as if the gravitational field has gone silent. These dark matter, dead zones don't make sense in our current models. The math expects dark matter to be everywhere, but the universe disagrees. And when the universe disagrees, we should listen. Some suggest that dark matter might not be perfectly uniform after all, that it clumps more than we thought, that it obeys laws beyond gravity, laws we haven't uncovered. Others argue that we're misinterpreting what we see, that gravitational lensing has limits, that something else, something subtle, is at play. But a few go further. They ask whether dark matter is selective, that it follows structure, not space, that it moves not in smooth halos, but in hidden paths, veins through which mass, time, and memory flow. And when there's no path to follow, it stays away. This flips the narrative. We've been treating dark matter like a fog, spread evenly, clinging to form. But what if it's more like a field, one that only activates under certain conditions? A field that isn't passive, but responsive. We know gravity bends space. We've seen it, measured it, lived inside it. But we don't know if dark gravity, if we can call it that, behaves the same way. Maybe it's not just mass that summons dark matter, but pattern, motion, structure. And when that structure isn't there, neither is it. That's why the absences matter. Because absence is not nothing. It's shape, it's boundary, its clue. And these forbidden zones, the places dark matter won't go, may be the map we need to understand what dark matter actually is. They could point to phase shifts, or new forces, or the limit of dark matter's domain. Or maybe they're the edge of something else, a second field, a deeper system, one that dark matter flows around, not through. Because if dark matter avoids certain regions, what's in those regions? We don't know, but nature is precise. Absence is not accident. Something is keeping those places clear. And in that clarity, a message appears. Dark matter is not a constant. It's a variable. It adapts. It withdraws. It responds. And that means it may be part of a system far more complex than we imagined. So we follow the absence back through time. We ask not where dark matter is now, but where it was in the beginning. Because before galaxies, before stars, before light, there were shadows. Before there were stars, there was darkness. Not the darkness of night, filled with silence and air, but a deeper kind, a primordial silence. No atoms, no light, no space as we understand it. Only potential. Then, from that potential, something shifted. The universe expanded, energy cooled, and from the chaos, structure began to form. But not from light, from shadow. The first thing to clump in the newborn cosmos wasn't visible matter. It wasn't stars or planets or gas. It was dark matter. Long before the first atom formed, dark matter was already gathering, moving slowly, collapsing gently, forming dense pockets, halos in the making. Invisible scaffolding, and on that scaffold, light would later hang. This is the foundational role dark matter plays. It doesn't decorate the universe. It defines its shape. It seeded the first structures long before the cosmos had cooled enough for hydrogen to form. Baryonic matter, the kind we're made of, was too hot, too energetic, too scattered. But dark matter? It was cold. It moved slowly. It didn't bounce or scatter. It formed clumps, halos, high-density regions where gravity could take hold. And into those invisible pockets, gas eventually fell. It was drawn in, not by light, but by the memory of mass. And when it cooled enough, it ignited. The first stars were born not in random places, but inside the curves shaped by dark matter. We like to think of the Big Bang as the beginning, but structure began later, and structure was dark. Even now, when we simulate the early universe, we don't start with stars. We start with fluctuations in the dark matter field, tiny differences in density, expanding with the universe and slowly collapsing under their own weight. Those fluctuations became galaxies, and the galaxies became clusters, and the clusters became walls. And between those walls, the vast empty places we still don't understand. But none of it would have happened without the dark, without the quiet, unseen mass that formed the bones of reality. And here's the part that haunts. We don't know why it clumped. We don't know what gave it form. We only know that it moved before light could. And if something precedes light, it may precede everything. It may be the first system, not conscious, but coherent, not alive, but forming the conditions for life. Maybe dark matter didn't come after the universe began. Maybe it's why it began. A framework that shaped how time unfolds, how energy flows, how matter condenses, not a byproduct, but a blueprint. If that's true, then everything we see now, stars, galaxies, planets, people, is just the visible echo of a structure that remains hidden. A shadow structure, still present, still shaping, still older than everything we call real. And if dark matter shaped the past, what is it shaping now? Because if it defined how the universe began, what will it define next? That's the question we turn to. From the origin of structure to its fate. We imagine time as a line, a smooth, unstoppable stream. One moment flows into the next, and we ride it forward like leaves drifting downriver. But what if that river has tides? What if time itself, our experience of history, emergence, and extinction, isn't as smooth as we thought? What if it rises and falls in rhythms shaped not by clocks or calendars, but by dark matter? We already know that dark matter shapes motion. It controls the rotation of galaxies. It stabilizes halos. It slows or accelerates the spin of stars around their centers. But motion isn't just distance through space. It's time unfolding. The Milky Way turns slowly. One full orbit takes about 230 million years. And in that span, stars migrate, systems shift, even the shape of the galaxy, its spiral arms, its bulge, its dust lanes, changes with the gravity beneath it. That gravity isn't just from stars, it's from something larger, older. Dark matter acts like a regulator, a hidden force setting the pace, not by intention, but by mass, by presence. And if it's been setting the pace for galaxies, has it also been setting the pace for us? Because Earth doesn't move through a vacuum. It moves through the halo. Our solar system is not fixed. It oscillates through the Milky Way's plane. It drifts through spiral arms, and it passes through regions of higher or lower dark matter density. Some scientists call these regions dark matter storms, zones where the invisible mass is more concentrated, like weather fronts in the cosmic sea. We can't see them, but they're theorized to exist. And if we drift into one, what happens? Some propose gravitational shifts, slight but measurable. Others suggest changes in radiation shielding, or neutrino interactions, or strange anomalies in atomic decay. A few go further. They wonder if these storms could affect human systems, subtle nudges in biology, consciousness, even civilization. It's speculative, unproven, but not impossible, because everything is connected to motion. Motion creates time, and dark matter shapes motion. It's the clock beneath the clock, the metronome we didn't know was ticking. And here's where it gets stranger. Galactic collisions are predicted events. Over time, the Milky Way will merge with Andromeda. But the timing, how soon, how slow, how chaotic, is affected by the gravitational envelope around both galaxies. Dark matter doesn't just affect individual orbits. It affects the fates of entire galaxies. It pulls them together, slows them down, speeds them up. It determines when stars are stripped, when halos overlap, when collisions happen. And so again, we return to the question: are we drifting toward something, or through something? Not in visible space, but in mark space. Maybe the events we call random, mass extinctions, climate shifts, global awakenings, are tied to the shape of the invisible matter we move through. We wouldn't feel it as force, we'd feel it as timing. Your place in time may have been chosen by something you can't see. And if that's true, if history itself flows along gravitational tides set by dark matter, then we have to ask, what else are we missing? Because the forces shaping our past may also be shaping our future. Dark matter isn't passive. It's a clockmaker, not in the sense of intention, but influence, silent, constant, guiding the rhythm of the spiral. And as we orbit, we may be ticking toward something, a convergence, a shift, or a silence. But if dark matter is shaping fate, why don't we hear more about it? Why are so few willing to chase the idea to its end? That's where we go next, to the boundaries of knowledge, and to the places where questions are no longer welcomed. For something that makes up most of the universe, dark matter is treated strangely. You would expect it to dominate headlines, command attention, inspire endless exploration. Instead, it's treated like a footnote, a quiet placeholder in every cosmology lecture, a shrug in every simulation. Yes, it's there. No, we don't know what it is. Onward. But behind the scenes, the story is more complicated, because there are things we've tried and quietly abandoned. Experiments that showed signals only to be dismissed. The Dharma Libra experiment in Italy, for example, reported an annual modulation in signal that many believed was consistent with dark matter flow through Earth's orbit. It pulsed like a wave, matching our passage through the galactic halo. But replication failed. Other teams couldn't confirm it. The data was questioned, the funding waned, and eventually, the results were folded away. Too noisy, too uncertain, too inconvenient. Other theories, too, have been pushed aside. Not disproven, but ignored. Plasma-based cosmologies, quantum gravity frameworks, information-based models that treat dark matter as code, not particle. Ideas that stretch the comfort of the field, that don't fit easily in a detector. And when science becomes institutional, these outliers are often treated as threats, because institutions need consensus, funding, predictability, and dark matter offers none of that. It is the perfect mystery, one that absorbs theories like a sponge, but never changes shape. It doesn't speak, it doesn't comply, and it doesn't reward those who chase it too far. So some stop chasing, others keep going, in silence. You'll find them on the edges of conferences, in the footnotes of papers, in small research groups working without attention. Still asking the question, what if dark matter isn't matter? What if it's structure, or memory, or the side effect of something deeper? A few have asked whether dark matter could be the signature of a simulated universe, the shadow of the rendering engine, the artifact of calculation limits at scale. Others have proposed that dark matter is a gravitational mirage, created by the warping of extra dimensions we can't detect. None of these theories are proven, but none are disproven either. They remain in limbo, not because they're flawed, but because they're dangerous. Dangerous to funding, to reputations, to the illusion that we're close to a unified theory. And so quietly, we build around the mystery. We adjust models, add constants, create frameworks that let us move forward without actually seeing what's in front of us. Maybe we haven't found dark matter because we're not really looking for what it is. We're looking for what fits. And sometimes the truth doesn't fit. The truth breaks things. It demands new models, new methods, new humility. And dark matter may be that kind of truth. One that rewrites what we think mass is, what we think space is, what we think we are. Because the silence isn't just physical, it's cultural. There's a quiet resistance to the idea that the most important substance in the universe might not be substance at all. And yet it continues to shape everything. Galaxies, timelines, possibility. So the real fear isn't that we'll never detect dark matter. The real fear is that we already did, and we ignored it because it didn't match the shape we expected. It asked too much, so we looked away. But now we can't, because the question has followed us. It's grown. It's changed. It's no longer about what dark matter is. It's about what it's doing, and what that means, not for galaxies, but for us. We call it missing mass. We picture it as an invisible scaffold, a ghostly substance cradling galaxies, shaping their orbits, curving their arms. It pulls, but it doesn't shine. It acts, but it doesn't speak. Or so we thought, because maybe dark matter isn't missing. Maybe it isn't matter at all. Maybe it's message. It sounds impossible, until you look again. Dark matter behaves differently than anything we've encountered. It doesn't clump like gas. It doesn't collide like stars. It doesn't glow, burn, scatter, or reflect. But it arranges, carefully, predictably, strangely. It shapes halos, threads, voids, every structure we see, every galaxy, every cluster emerges from its invisible architecture. It doesn't seem random. It seems encoded. And when systems don't behave like matter, we should ask whether they are something else. Maybe dark matter isn't a thing. Maybe it's a language, the way it arranges itself across space, smoothly, proportionally, recursively, resembles the syntax of systems, not the chaos of collision. It doesn't just fill the universe, it structures it, like code in a simulation, like DNA in a cell, like thought in a mind. It behaves like information, not in the casual sense, but in the technical one. In physics, information isn't metaphor. It's conserved. It has laws. It can be stored, moved, compressed. And dark matter seems to obey those laws. Its distribution is efficient, minimal, self-stabilizing. Where visible matter is reactive, bouncing, radiating, degrading, dark matter is persistent. It holds form over billions of years. Not static, but continuous. It behaves less like a substance and more like a signal, a structuring current within space itself. And if that's true, then gravity may not be the message. It may be the medium. Just like sound isn't the music, air is. Gravity is the carrier wave. Dark matter is the modulation. And what it modulates might be structure itself. That's why scientists have started comparing the distribution of dark matter to neural networks, webs of connectivity that evolve over time, optimizing for flow, not form, or to fungal mycelium, vast underground networks that shape ecosystems, responding to nutrients, sending signals, learning without a brain, or to the structure of the internet, clusters and links, recursive loops, organic scaling. None of these are perfect analogies, but they echo a deeper idea, that dark matter may be organizing the cosmos, not just enabling galaxies to form, but telling them how. If galaxies were just gravitational accidents, their shape would be unpredictable, messy, uneven. Instead, spirals are common. Halos are consistent. Cluster formations repeat. The patterns whisper of instruction. And here, ancient ideas begin to re-emerge. Not as myth, but as pattern memory. The Greeks called it logos, the divine ordering principle. In many traditions, creation began not with matter, but with word, with structure given to chaos, not by force, but by form. Today, we call it dark matter. And perhaps that's all it is. Not mass, but syntax. The fundamental order of space before light, before particle, before time. Not meant to be seen, only followed. And suddenly, the galaxy changes shape in the mind. It's no longer held together by something unseen. It's instructed by it, not restrained, but rendered. What if dark matter isn't holding the galaxy together, but telling it how to behave? That idea doesn't belong to fantasy. It belongs to the edge of physics, where quantum information theory, gravitational entropy, and emergent space-time begin to blur. Some physicists believe the universe is fundamentally computational, not a machine, not a mind, but a process. Dark matter in this framework is not material. It's the logic of the system, the instruction set, the silent language written across space to define what becomes real. And if it is a language, then someone, something, must be able to read it. That's where we go next, not deeper into space, but into perception, into the eyes that look into the dark and see a pattern looking back. Observation is not passive. In the quantum world, it's intervention. Watch a particle, and its behavior changes. Measure it, and it picks a state. Don't measure it, and it remains a probability, a ghost of possibilities. This isn't theory anymore. It's experiment. The observer effect is real, but we've long assumed it applies only to the very small, to electrons, photons, atoms, that it fades in the face of mass. But what if it doesn't? What if observation continues to shape reality, even at cosmic scales? And what if dark matter isn't elusive, but responsive? There have been experiments that hint at something strange. Dark matter detection events that spike, then vanish. Seasonal variations that repeat, almost like the Earth moves in and out of a current. Signals that appear to come from one direction, then shift. And always, the response from the scientific community is the same. Error, noise, equipment, drift. But what if it's not error? What if the attempt to observe dark matter changes the relationship itself? We're trying to catch a thing, but what if it's not a thing? What if it's a field that responds not to energy, but to attention? We assume nature is indifferent, but indigenous traditions around the world saw it differently. To them, the sky wasn't inert. It was alive, not in the way animals are alive, but in the way a conversation is alive. The stars were not objects, they were relatives, storytellers, participants, The act of looking up was not a study. It was a relationship. You gave your attention. The sky responded. You named it. It remembered. In many cultures, the galaxy was not a spiral of light. It was a being, a path, a guide. They had no detectors, no equations, but they understood the principle. To observe is to affect, and to affect is to participate. Perhaps modern science struggles with dark matter, not because it's beyond detection, but because it can't be reduced. Because the act of hunting collapses the field. Because dark matter is not meant to be isolated. It's meant to be entered, and the harder we try to trap it, the further it retreats. Some researchers have quietly asked if dark matter detection is directional, that it depends not just on tools, but on orientation. Others speculate that the field fluctuates in ways tied to larger cycles, planetary alignments, cosmic background shifts, even consciousness patterns, too fringe for funding, too structured to ignore. And here, again, the twist emerges. What if dark matter doesn't reveal itself because it was never meant to be hunted? What if it only responds to the right kind of attention? Not measurement, relation. That sounds mystical, but it's not. In physics, we already accept that observation changes behavior. We just never scaled the idea up, never asked what it would mean for a galaxy, never asked what role we play in the field we move through. Maybe consciousness isn't confined to neurons. Maybe it's entangled with structure. And maybe dark matter is the mirror it reflects in. A mirror that can't be touched, only entered. And if that's true, then detection isn't a matter of engineering. It's a matter of approach, of listening, not pressing, of invitation, not interrogation. Because not everything hidden wants to be found. Some things wait to be recognized, and when they are, they change shape. Dark matter may not be hiding. It may be waiting for the right frame of relationship. And that relationship might begin now. Because if the observer changes the field, then we must ask, what are we? The ones who observe. And what happens when the field begins to respond? The deeper we look into space, the more it begins to look familiar. We expected chaos, random swirls of gas, scattered stars, entropy stretched across blackness. But what we found was structure, not just in stars, but in the darkness between them. Dark matter doesn't clump randomly. It forms filaments, long interconnected threads. Where they intersect, clusters form. Massive hubs of galaxies, bound invisibly. Between these hubs lie voids, vast, silent stretches where almost nothing exists. Zoom out far enough, and the Milky Way becomes a node on this web. But zoom in, way in, and something other happens. You begin to notice the pattern. It looks like a brain. The dark matter web of the universe, its long strands and glowing junctions, mirrors the structure of neural networks. And this is not poetic metaphor. Computer scientists studying both have noted the same distribution, the same topology, the same architecture of connection and silence, neurons and galaxies, synapses and star clusters. The shapes are eerily alike, and once seen, the resemblance lingers. Of course, resemblance is not proof. The brain is biological. The universe is not. But the shape raises a deeper question. Why do systems that process and evolve information, whether made of neurons or galaxies, take on this same form? It may not be coincidence, because dark matter doesn't collide. It doesn't decay. It connects. It forms channels, holds structure, shapes the motion of everything inside it, just like the white matter in your brain. And here, a thought begins to flicker. What if the Milky Way doesn't behave like an object, but like a process? What if it's not a place where matter happens to exist, but a system that stores, transmits, and evolves information? The word for that, in the world of philosophy, is mind. And some thinkers have begun to wonder whether consciousness might not be limited to biology. What if it emerges from complexity? What if it's a property of systems that reach a certain threshold of density, feedback, and flow? This is the idea of cosmopsychism, the view that consciousness might not be confined to skulls or species, that the universe itself, through structures like the Milky Way, might manifest something like awareness, not human, not sentient, but structured, coherent, reflexive. It's a radical idea, but not unscientific. Complex systems evolve behavior, and behavior implies pattern. Astronauts who spend time in orbit speak of a strange shift, an emotional realignment that changes how they see the world. Some call it the overview effect. Others call it awe. But more than one has described the galaxy itself as suddenly familiar, as if staring into something not just massive, but intimate, not just old, but knowing. The Milky Way begins to feel less like a location and more like a presence. This isn't religion, it's reflection. A quiet recognition that maybe we feel at home in the galaxy, because the shape of the galaxy is already inside us. We are made of stars, but we are also shaped by the field those stars form. And that field behaves like a memory system. It stores paths, influences outcomes, remembers form, not with words or thoughts, but with gravitational pattern. And so we come to a strange symmetry. We searched the sky for meaning and found a structure that thinks like we do. So the next question is quiet, but unavoidable. If the galaxy resembles a mind, what is it remembering? Stars are beautiful, but they forget. They burn brightly for a time, then die, scattering their elements, erasing their origin. Nebulae drift, systems collapse. The sky refreshes itself every few billion years. But dark matter remains. It doesn't burn. It doesn't fuse. It doesn't explode. It persists. And in that persistence, it remembers. Not in the conscious way we do, not in words or images, but in shape, in gravitational patterns that refuse to vanish. The Milky Way is not static. It has changed. It has consumed smaller galaxies, formed streams of stars that stretch like ribbons across the sky, remnants of long-lost systems torn apart by motion. We can see these streams in visible light, but eventually, even those fade. Stars disperse, clusters dilute, trails vanish. Yet the dark matter halos of those absorbed galaxies, they don't go away. They blend, they fold into the existing structure. And in that structure, their signature remains, like scars beneath skin. Astronomers can map these remnants not by looking at light, but by detecting tiny gravitational anomalies, subtle curves and shifts in the halo that tell of collisions long past. This is cosmic memory, not stored in data, stored in form. A loop in the halo, a twist in the velocity map, a bulge where none should be. The galaxy, in its silent scaffolding, remembers. The idea is haunting, because it means the Milky Way carries a history longer than the light can show. A record not of what shines, but of what shaped it. We tend to think of history as light-based. Photographs, writing, echoes of radiation from the Big Bang. But those are snapshots. They fade. What doesn't fade is gravity. And dark matter may be the most faithful recorder the universe has ever known. It keeps no stories, but it keeps the results of stories. Long after the stars have changed position, the structure remains, as if the galaxy is a kind of archive, not of event, but of influence. It raises a question. If dark matter stores memory, what is it remembering for? Memory, after all, is only useful if it serves function. In the brain, memory supports learning. In ecosystems, it supports adaptation. In galaxies, could it support evolution? Could the gravitational field itself nudge formation patterns? Could ancient collisions influence where stars form next, or how systems behave? We don't know, but the persistence is undeniable. And memory does not require consciousness. It requires persistence and pattern. And dark matter is the most persistent, patterned thing we know. So when we look at the Milky Way, not in light, but in gravity, we see a different story. We see a galaxy shaped by what it's been through. A galaxy that remembers the galaxies it absorbed, the paths it crossed, the structures that passed through it. And by moving through that memory, we become part of it. Our planet, our orbit, our place in the field. We are not separate from the shadow. We are a current in its memory. And maybe, just maybe, that memory is not passive. Maybe it shapes what comes next. Because if the galaxy remembers everything, even what the stars forgot, then we are drifting not through space, but through a story still being written. Dark matter has always been painted as a backdrop, a supporting actor, an invisible frame, something that once shaped the past, but now merely holds space for what shines. But what if that's wrong? What if dark matter isn't finished? What if it's not just holding the Milky Way together, but shaping what it becomes? Right now, star formation in the Milky Way has slowed. Vast regions remain stable, while others quietly collapse. Spiral arms stretch and breathe like slow lungs. The central bar rotates with a rhythm older than any species. None of this happens randomly. Dark matter is not inert. It exerts gravitational influence across scales, from tiny dwarf galaxies to the Milky Way's halo. It pulls, it folds, it directs. Some researchers believe dark matter shapes the rate at which stars are born, not by causing formation directly, but by controlling the environment. The density of clouds, the pressure of collapse, the balance between motion and stillness. Even now, the halo that surrounds the galaxy may be sculpting its future, but the twist is deeper. Because we keep speaking of dark matter as if it's acting on the galaxy. What if it's acting through it? Not an external force, but an internal mechanism. Not a substance, a system. There's a shift, subtle but world-altering, that happens when we stop asking, what is dark matter made of? And begin asking, what is it doing? Because its behavior is strange. It avoids collision. It stabilizes motion. It forms predictable patterns in unpredictable space. It behaves like a logic layer, not of code, but of physics. And that logic may be recursive, iterative, a system using mass and time and gravity as tools, not for output, but for process. It begins to resemble something else, computation. We're not saying the universe is a computer, but we are asking whether the Milky Way operates like a program, a dynamic field where states evolve not randomly, but according to underlying rules. And if dark matter is the substrate of that program, we are not just floating in it, we are part of it. We thought we lived in a galaxy, but what if the galaxy is something we're inside of? Not a place, a process. And our awareness, our ability to observe, to reflect, to choose, might not be incidental. It might be emergent. Dark matter connects the galaxy. It holds the shape, not statically, but dynamically. And perhaps that shape is not just physical. Perhaps it's informational. Perhaps what we call matter and what we call mind are both phenomena that emerge from deeper processes, and dark matter is one of the bridges between them. In this view, dark matter is not a gap in understanding. It's the condition of understanding itself, the operating system, not the output. Ancient cosmologies told stories of the cosmos as a living intelligence, a presence, a breath. They weren't measuring particles, but they sensed structure. They named the sky not with numbers, but with meaning. And maybe meaning isn't something we add. Maybe it's something the galaxy was always generating, beneath light, beneath thought. Modern physics now plays with ideas like the holographic principle, that everything we see is a projection of deeper laws, that space itself might be emergent, that mass is memory, that time is compression, and dark matter. It fits nowhere and everywhere. It is mass without form, presence without explanation, action without collision. Like the ghost of a deeper rule we haven't named. Maybe the Milky Way doesn't behave like a thing because it's not a thing. It's a language, a rhythm, a self-balancing structure that includes us, not as observers, but as components. And when we see this, when we step outside the assumptions, we find the most unsettling realization of all. We were never outside the system. We are the system, trying to understand itself. And dark matter was never a clue to something hidden. It was always the interface. So the question now is not what dark matter is. The question's, what is it doing in us? That leads to the final moment, not of fact, but of decision. The story doesn't end. It opens, like the arms of a spiral, like the drift of stars, like a question that refuses to collapse. We've traced invisible forces. We've questioned everything we thought we knew about space, structure, substance. And now, in the final moment, the voice goes quiet. Because this isn't about knowledge anymore. It's about relationship. You've heard the data, seen the models, imagined the web of matter you cannot touch, felt the slow shift from observer to participant. Now comes the invitation, not to believe, not to explain, but to reframe. Dark matter is not just a scientific mystery. It's a mirror. It reflects the limits of our sight, the edges of our thought, the shape of questions we weren't taught to ask. Because the real forbidden idea was never about mass or gravity. It was about meaning. What if the universe is not meaningless? What if the silence between stars is not emptiness, but invitation? What if dark matter is not resisting detection, but waiting for participation? Ancient cultures didn't try to isolate the cosmos. They related to it. They lived within its patterns, dreamed in its shapes, made decisions by its rhythms, not out of ignorance, but out of recognition. They understood that meaning is not assigned. It is discovered, like light blooming through a lens, like motion carving memory in shadow. And here, as the narration slows, as the last concepts settle like dust, the question rises, soft, clear, and final. What will you do with this? You've learned what shapes the galaxy. Now the question is, what will it shape in you? Because everything we've explored, dark matter, gravity, halos, time, is not just out there. It is here. It is within. It is part of the very way you think, move, feel. You are not apart from the spiral. You are a current in its flow. And perhaps that current moves not toward a destination, but toward awareness. Maybe the galaxy has always been inviting you to wake up, not to fear, not to conquer, but to see. Not just stars, but structure. Not just space, but participation. And so the story ends without an answer. It ends with a door, a turning of the gaze, a widening of the frame. You are part of something that cannot be named, something that moves in silence, that binds galaxies, that remembers without memory, that shapes without shape. It has no voice until you give it one. It has no meaning until you make it one. The galaxy doesn't end in distance. It ends in you. If dark matter truly shapes the Milky Way, then much of the galaxy we call home is being guided by something we still do not understand. The stars we see may only be the visible surface of a far larger hidden reality. And maybe that is the most humbling thought of all, that even now, in our own galaxy, the greatest force around us is one we cannot yet see.